Hello and welcome to Hero Appliance Academy in the Multimeter series. This is part 2. Today we're going to take a more in-depth look into how to use the multimeter and each of its basic functions. And like always, don't forget to like and subscribe, and let's get started. All right, so first let's get started with the basic voltage checks. We're gonna start with AC voltage. AC voltage has a wave symbol, kind of like this. And that's because it represents the alternating nature of the voltage. It reverses direction periodically like a waveform, typically a wave sine. Unlike DC voltage, which flows in one constant direction, AC voltage rises and falls, switching between positive and negative. The wave symbol visually reflects this oscillating pattern. So what are some advantages of AC voltage compared to DC voltage? Some of those advantages would be like easier to transmit over long distances. AC can be stepped up or down in voltage using transformers and reducing energy loss. It's widely available. You'll find this in your homes, businesses, making it compatible with most appliances and equipment. It can power motors very efficiently, especially useful in large appliances like washers, dryers, and HVAC systems. And of course, it supports multi-phase systems. Three-phase AC systems are ideal for heavy industrial loads and commercial power. So where are some of the places you'll see AC voltage at? Let's take a look.
So you can find AC voltage in places like this in your outlets throughout your home. In this outlet here, you can see it's got a T shape on the common side of the outlet, and this is to allow for a 20 amp plug to be plugged into this outlet. And that's the difference between the 20 amp and the 15 amp plugs, as the 15 amp plugs do not have that T-shaped side on the common, and that's to prevent 20 amp cables from being plugged into 50 amp outlets. Now, you never want to assume that the outlet is a 20 amp circuit. You want to verify at the breaker, because you can find that these outlets can be installed in the wrong circuits, like finding a 20 amp outlet on a 15 amp circuit and vice versa. You'll always want to check at the breaker. Here's another example where you can find AC voltage, and this is just a standard regular outlet. As you can see, it looks a little bit different than the 20 amp circuit. This should be on a 15 amp circuit, and this is a standard outlet. You can also find AC voltage on larger outlets like these. These are designed for 220 to 240 volt. Usually you'll find these on 30 to 40 amp circuits. As you can see, this one's marked for a 30 amp. Now, these larger 220, 240 volt outlets can come in 3-prong or 4-prong. These outlets are designed for larger appliances like dryers, ranges, and so forth.
All right, so now let's learn how to set our multimeters and how to use that multimeter to check AC power and outlets and appliances and different things like that. Let's go. Let's talk about how to set up your meter leads onto your meter, because you probably need to know, where do my leads go? So most of your meters are pretty straightforward. There's only going to be 2 spots. You have the common and your line side. Common is always going to be black and your line's always going to be red. So that's your positive and negative. That's going to be pretty standard across. In most manufacturers, you can see here, they kind of even have it color coded. They have common as black and your positive lead there as red. So you can't really mess those up. But in certain situations where you have meters like these, they have other options. And some of these meters will have the 10 amp fuse, and that's for measuring larger currents. Anything larger than 200 milliamps, you want to switch over to the 10 amp. Of course, these are not amp clamps, so you're going to have to use the leads, and that's why they give you that option. You're not going to have that with these. These have clamps. You just switch to amps. As you can see here, I'm going to switch over to amps. Alternating current, AC voltage. You see the line there. At that point, I can check amp draw. Same thing here. If I was to switch to my voltage, as you can see, I'm checking AC volts. If I hit select, now it's giving me amps and voltage, and I can use my clamp to check my amperage. That's the difference when it comes to these that have different inputs, and that's just for fuse depending on the current reading, because these don't have clamps. So you're gonna have to use your leads. Not practical, and not anything you're ever gonna have to use in field service. These are not going to be the ones you'll use for checking amperage, like the ones that you're going to use to actually have the clamps. They're designed for that. On these, of course, you would just place your red leads on your input, and your black lead will go on your common, like such. It'll be the same thing on these. You want to just make sure that you're paying attention to what you are selecting. Other meters are pretty straightforward and they only give you 2 areas for you to put in your leads, so you can't really mess that up. And that's how you get your meter ready to go. And then you make your selections depending on what you're testing. Okay, so now let's check AC voltage. One of the most common and most important checks you can make with a multimeter. We're going to be demonstrating this on a standard outlet checking for AC voltage. We'll also show you how to check proper polarity of an outlet as well. So let's go. Okay, now that we have our leads installed, let's start by setting our multimeter to AC voltage. That's the setting with the wave symbol, usually marked with the V and the wave symbol. Keep in mind that other meters, like the fill piece, will label it as VAC, as you can see right here. So keep that in mind, it might be a little bit different. All right, on this one, we're gonna go ahead and set it to AC voltage. So we're just gonna turn the dial right there to volts AC. And you can see we have the wave sign there at the bottom and the V for voltage. All right, let's go to the outlet and give this a test. So we're here at our outlet, and a few things that we have to point out here, and that's going to be what is your common side, your neutral side, and then your positive or line side, your hot side. So all outlets, you will see that they'll have a larger slot and a smaller slot. And of course, you'll have the little half circle here at the bottom. The larger slot, that's going to be your common, your neutral side of the outlet. The smaller side, that's going to be your hot side. That's going to be where the line power is. And of course, this bottom one, that's going to be your ground. So let's show you how to test that. All right, so now insert your black lead, that's your negative. That should go on your neutral side, your common. And now use your red lead, that should go on your hot side, your line. All right, as you can see, we're reading 122 volts AC. Now let's check for proper polarity. So next, test hot to ground. So we're gonna move our neutral, our black lead, go to ground, and you should also read 120 volts. And as you see here, we're reading 122. Finally, test neutral to ground. This should read very close to 0. If not, there could be a grounding issue. All we're gonna do is go right here to our neutral. We're not getting anything, so that's proper polarity. Now, if I was getting voltage here, if I was getting 120 here and nothing from line to ground, that could mean that I have reverse polarity, which could affect the appliance operation or cause unintentional failures. And that is how you check AC voltage and proper polarity of an outlet. Now let's talk about DC voltage. The symbol for DC voltage is typically a solid line above a dashed line, like this. Sometimes it'll be represented just by the letters DC or VDC. This will be dependent on the type of meter that you have. The solid line represents the constant voltage level, and the dashed line shows that the current does not fluctuate like AC does. So what are some of the advantages of DC over AC voltage? Well, number one, it's stable and constant. It's ideal for electronics that need steady voltage, like your refrigerators that have multiple controls that need proper communication between all the different controls. For that, you're going to need something that is steady and stable. So DC voltage is typically used for sensing circuits and communication lines. It's more efficient for short distance. Now, like AC voltage, that can be spread for long distance. Unfortunately, DC voltage on long distance can start to drop and lose its potential, but it's definitely more efficient for short distance. There's no need for conversion, especially on low voltage applications. It really helps with sensitive circuits that rely on that communication. And it's the primary voltage that's used for storage devices like batteries. Now let's check DC voltage, which you'll commonly see in batteries and control boards. With appliances nowadays, DC voltage is becoming more and more common when checking control boards, regardless of the appliance, from washers, refrigerators, and so forth. So having the knowledge on how to properly check for DC voltage is pretty important. All right, so let's get to it. Now let's check DC voltage, which you'll commonly see in batteries and control boards. We're going to use this field piece SC440, and on the field piece you can see that they do not use the common DC symbol. They actually just label it out as VDC, as you can see right there. So to switch this meter to DC, we're just going to turn our knob until we get to DC.
As you can see, we have DC there on the side, and we're seeing the V, so we're checking DC voltage. That's going to be a little bit different than some other meters like the Klein here, and you can see they actually have the DC symbol, and it's all under the same setting. Meters like these, you'll switch to voltage, and then you have to select between AC or DC. You use the selecting key. As you can see, we have our wave symbol for AC. Once we hit it, now we have our line and our dashes, that's DC. So that's some of the difference that you can see. All right, let's start with something easy, a AA battery. So on our AA battery, you can see here we have the plus for our positive side and our negative for our negative side. That's pretty important when you're checking DC voltage, and we'll show you here what that means. Okay, so red on the positive and black on the negative, and we're reading 1.5 volts DC. Now if I reverse my leads, you'll still get a reading, it would just be negative. That means the polarity has flipped, and you can see there we have the negative. That just means that we reverse the polarity, but it's still reading the same. That's some of the difference you'll see between DC and AC. Because AC is constantly changing between positive and negative, it doesn't matter if you flip your leads or not, you'll always get the same reading. But on DC voltage, you'll have the standard reading, and then you'll have the negative reading depending on if you flip your leads. So if you ever see the negative sign, don't worry, just flip your leads and you'll see. That's all it is. It's just reversing the polarity, and that's just what it's reading. That doesn't mean that it's actually a negative reading. So hopefully that helped. Now let's check it on an actual control. All right, we're on this refrigerator here, and we're going to be testing this upper control, which is our power supply control. We have AC voltage coming in, and this control board converts it to DC and outputs DC voltage to certain components like load sensing circuits, communications, user interface, and other components that need DC voltage. So let's show you how to test that. So first thing I want to do is just show you here, we're going to switch it to AC voltage. We have our meter here set to AC voltage, and I'm just going to check the power coming in. Doesn't matter which direction my leads are in, if they're reversed or not. And you can see 123. Even if I was to reverse it, still going to read the same 123. AC voltage does not matter on your leads as far as positive or negative. They're always going to read the same. Now let's switch it to DC. Switch to DC here. There we go. We're on DC. We're going to check our output. And you can see that I'm getting negative 12.7. That does not mean that I'm receiving negative voltage. I'm actually reading 12.7, but because my leads are reversed, I have that negative sign. So all I gotta do is reverse my leads, put it back on there, and you can see 12.7 volts DC. That's all it is. If you ever see that negative sign on your readings, don't freak out. It just means your leads are reversed. No big deal. You can flip them, and that is how you check DC voltage. Okay, so now let's talk about how to check a capacitor. We did talk about capacitors on the previous videos and some of the important reasons why there's capacitors on appliances. Capacitors are very common components in appliances. It can be found on a wide range of appliances, like in washing machines for drive motors, in refrigerators being used for the compressors. They can even be found on filter boards or be used as filter boards themselves to clean up any frequency issues. So capacitors are a very common component that you must know how to properly test. And if you're not familiar with the capacitor symbol, this is what the symbol will look like. Keep in mind, like I've stated on the previous video, they could also use the microfarad symbol, or they can label it as MFD like some meters do. So let's get into that now. Let's get to it. Alright, so here's a washing machine motor capacitor. You can see it's a 50 microfarad capacitor and rated up to 250 volts. Let's show you how to test that. Alright, we're going to first use the cheap Amazon meter. You can see it's got a capacitor symbol there. We should be able to check the capacitor. Discharge your capacitors when you're testing them or before you touch them. And what you can do is short them out. That's either using insulated needle nose pliers or insulated screwdrivers, and you just want to touch both of those. Now this has already been discharged, so you're good there. All we're going to do is just touch both of those prongs there,
There we go. And some meters do have a delay. As you can see, we're reading 50 microfarad, so that's reading correct. Let's try a different meter. All right, this is on a Klein, so we're going to switch that to our capacitor. There you are. Give it a second to register. See, it's reading. There it goes. Same reading we're getting on the $20 Amazon meter. And here's two field pieces now. Even though they're both field piece units, you can see there's a slight difference on selecting the microfarads. And on these, field piece uses MFD instead of the microfarad symbol or capacitor symbol. The SC440 has a dedicated microfarad test point instead of having to select through the different settings on the SC260. Let's give that a try. All right, so on the field piece, we'll switch it to MFD for the microfarads. There's our symbols. Let's turn that light on so you can see. And again, I'm just going across my 2 pins. Give it a second to read. And there it goes. So again, all within the same range. That is how you're checking the capacitor. There is these little holes on the side of the prongs. You can go to them, or you can just touch the metal. However you want to do, as long as you're making contact. All right, so let's talk about tolerance. So when you're testing a capacitor, is 50 what you want to see every time? Is 49 a bad capacitor? Is 51 a bad capacitor? You kind of have to understand on the capacitor, they'll tell you what your tolerance is. So on this one here, you can see it's plus or minus 5%. That means I could be, 5% of 50, that's going to be around 2.52 microfarads. So that tells me anywhere between 48 to 52, I'm within range. So it's important to check your capacitor's tolerance. It's usually written really close to the microfarads rating. This one tested good no matter what we did. Make sure that you are checking your tolerance. In appliance repair, being able to test a diode is pretty important. From testing them on control boards to testing LEDs. Believe it or not, that's what the name LED stands for, light emitting diode. A diode is an electronic component that allows current to flow in only one direction. Think of it like a one-way check valve for electricity. It blocks current in the opposite direction, which helps protect circuits and direct electrical flow. We often see diodes used in dual water valve and other components that are wired in parallel to prevent backfeeding or cross-activation. The diode ensures that current flows only in one direction, allowing multiple components to be shared in a circuit without interfering with each other. If you're not familiar, this is what the symbol will look like on most of your multimeters that do offer this option. Now let's show you how to properly test a diode and an LED. Let's get into it. Alright, to show how to test diodes and LEDs, because an LED is just a diode, that's what LED stands for, a light emitting diode. So we could test it the same way as we do a diode, and it should light up the LEDs. So here's a really small diode, and as you can see, there's a little white line on one end. That is going to be the negative side of the diode, and the other side being the positive. And that's the cathode and the anode of the diode itself. Keep in mind that not every meter will be able to check a diode, and some will be able to check it, but it would require you to apply a voltage. Now these meters here do apply a voltage to the reading because a diode, it only lets voltage go one way. AC voltage is alternating, so it's going back and forth. It's only going to let that AC voltage go one way. It will not be able to come back. So you can't have any type of backfeed or anything like that when you're dealing with a diode. Alright, so we're going to set it to diode test. And remember your positive and negative leads, that's pretty important. So black being our negative and red being our positive, it should read voltage across. Get a good contact here. There we go. And should be getting anywhere between 2 volts to up to 8 volts, depending on your meter, but this will drain some of your battery. So it is applying a voltage. As you can see, it's letting voltage through. Now, if I reverse my leads, if this diode is okay, it shouldn't read anything. And there it is. It's not reading anything. That tells me this diode's okay. If I was reading voltage both ways, that means that this diode has failed. Other meters, you will have to use the select key to change from your selections. You can see ohms, continuity, kilo ohms, and then we have our diode and the voltage reading there. And using that same theory, negative and positive, there we go. We're reading the same. If we reverse, it's still reading OL, which is outer limits. All right, for LEDs, what you're going to do is going to be the same thing, your positive and negative, and what it's going to do is that voltage should turn this LED on. Keep in mind that not all meters will be able to light up an LED, and not all LEDs will light up. It really depends on what kind of voltage that LED requires. These little low voltage DC LEDs, you could probably get them to light up. These bigger LEDs that are on 120 volt circuit, no, these will not work. The DC ones will. So if we just go across our pins here, positive and negative, as you can see, I'm actually turning the light on and off with my leads because I'm using the diode. It is sending voltage, sending 2.4 volts right now. That's enough to at least light them up. Are they going to be super bright? No. But that will tell me if this LED is good or bad. So if you have a refrigerator that the LEDs are out, and because they're usually series circuits, you're not sure which one it is, using the diode tester on your meter, that's a quick, easy way to isolate those LEDs. Just apply that voltage to them and they'll come on. Okay, now let's talk about amperage or current. That's how much electricity is flowing through a circuit. So this is where a clamp meter becomes your best friend. Most multimeters can measure small currents directly, like we talked about in our previous video, where some of the multimeters will have a 10 amp circuit built into them for smaller currents. But doing this usually requires breaking the circuit and wiring it in series, which isn't ideal for appliances. This is where the clamp meter really comes in and will help you check amp draw. So let's get into that and we'll show you how to properly check amps on a circuit. Okay, on this refrigerator here, we're going to check the amp draw on the defrost heater. Now, the defrost heater comes right off of this P2 connector right here. You should be able to see it says P2 up there, and that's going to be this first pink wire right there. That is for the defrost heater. Now, to get a clamp in here, it's going to be pretty hard. You can't clamp around the full wire harness. You need to clamp only the wire that's going to the load. That's going to be the line voltage going to the heater. So what I can do is I have some space right here. So if I go through this harness here and find my defrost wire, what I can do is just pull it out enough to clamp it. And here it is. Let me isolate it. All right, now I have room right here. Doesn't mean I have to be at the connector. As long as I can find that wire anywhere else in the harness, I can check it somewhere else. And what we're going to be doing is we're going to be using the climb here to check it. So just to show you here, I'm going to clamp it around just that wire. There it is. And that's what you're trying to do. So when you're checking amp draw, all you need to do is clamp the wire inside of the clamp here. You want to make sure that you're not clamping multiple wires, and you always want to use your line wire, your power wire, to the load. You don't want to use the neutral or the common side of the load, because that is the return current back to the breaker panel. And because electricity is always trying to find balance, some of the unbalance can be seen on the common side, so you want to avoid that. So when you're checking amp draw, you always want to check your line, your positive wire going to your load. Don't want to check it on the common side. So we got our clamp here. Let's go ahead and turn on this defrost heater so you can see what's going on. Okay, so what I'm going to do is switch to amps here, and that's going to be this A right here with our wave sign. That's going to be amperage, and of course that is AC voltage. You can see it down here at the bottom. And this meter does also do direct current, but of course we're checking AC voltage. So let's go back to our wave sign and let's turn that heater on. Alright, so the heater's on. You can see I'm pulling about 3.4 amps. If I take it off, you can see I'm not getting anything. If I clamp it on the wire, there it is. I'm getting my amp draw. And like I stated, you only want to be on one wire. You're not going to get anything if you do the whole harness. As you can see, I'm doing the full harness here, and I'm not getting anything. It's just not going to be able to read. You need to isolate just your circuit and make sure that you're isolating only the power wire, the main wire going to that load. And that's going to mean you're looking over your schematics and learning how to read it
and understanding which wire you need to check your amp draw to. And situations like this will be really helpful where you don't have to take a freezer apart to check the operations of a defrost heater. You can turn the defrost heater on, and if you got correct amperage, that's going to tell you that the defrost heater is working and the defrost heater is okay. That's going to save me time on my diagnosis. So if I have a visual indication of a defrost heater failure, there might be something else going on because clearly my heater is not the issue. So there's got to be something going on with the activation of that heater itself. And if you're not sure what amperage you should have when you're checking a load, you can always check the tech sheets or schematics to understand what the wattage potential, resistance value, voltage, and everything like that goes to that load. And you should be able to use Ohm's law to be able to determine what kind of amp draw that load is going to be pulling. And on this one, of course, we're checking good. Now let's go do the same thing on a compressor to show you how to check the amp draw on the compressor. All right. This is a pretty standard compressor with a start device. Keep in mind that variable speed compressors on inverters, you're not going to be able to check amp draw. They're variable speed, so compressors like that, you're checking for wattage. Amperage is not going to be something that you're going to be able to do. So if you see an inverter box, you're not going to be able to check the amperage. Check wattage instead. So of course, this unit here has got a star device. This is a single speed compressor, so we can check what the amp draw is on. All right, so keep in mind that you got the blue wire here. That's your live wire. That's your power going in. Here's your white wire, that is your common, your neutral going back to the breaker panel, that's your return line. And you can see that that is also shared with the condenser fan motor. Here's a condenser line wire and here's a condenser common. You can see they're all shared. So you want to avoid using that common wire, especially up here where you can accidentally check amp draw to your fan motor instead of your compressor. So always check your power going into a load. So let's go ahead and check this out and turn the compressor on. All right, again, I'm going to set to AC amperage. Right there, we have our A for amps, and we have our wave sign there. Let's turn this light on. There it is. And let's go ahead and check that. All right, we got it connected to the compressor here on our live wire going to our compressor. Let's go ahead and crank this compressor on. All right, as you can see, we're getting about 0.8, 0.7 amps on that compressor. And because it is R600, this is going to be running on lower amperage. So again, you never want to check your common wire, you want to check line. And so I can go right back to the line here, check it again, 0.6 amps. And that's the easy way to check amp draw. You just want to be on a live power wire going to your load and clamp just that one wire inside your clamp and make sure that you have the correct set. And that's it. All right, now let's show you guys how to test your leads. This is something you want to do quite often. Make sure your leads are in good condition and they're reading accurate. There we got the 440 here, so let's show you here what to do. And this is something you can probably do every time you use your meter. And what you want to do is set your meter to ohms and check the resistance of your wiring and your leads to make sure that you're good. You should read 0.4 or lower, and you should also be able to get your continuity beat. So let's check these out. All right, so let's put them together here. And you can see we're all over the place. We're all over the place. Move the leads, but you can see we're getting 23.5. Just moving the wiring around. Up, there we go. We're getting them lower, but it's all over the place. So you know these leads are bad. And that's something you're going to do. If you're going to check continuity, check resistance of a component, you're always going to check your leads, you know, almost right away. If you're going to check continuity, most guys will put the leads together right there and then just to make sure everything's working. So you want to do this often. Make sure your leads are okay. And there it goes, back to working. We're going to compare now to the cheapest and the worst leads we got on this video, which is the ones that come with the cobalt meter. And these are super thin, they're flimsy, they're just god-awful leads. But let's put these on and let's try these out. All right, we got the cobalts on here. Let's give these a try. 0.1, 0.2, really just staying within range. These are good.
Not saying that these won't read good. I mean, they might read okay, but as you saw, depending on how you hold them and how you move them, you're gonna get issues. So make sure you are checking your leads. All you have to do is check the resistance across your leads together, touch them together, and again, you should be able to read around 0.4 or lower. That's what you're looking for. Anything higher, 0.7, 0.8 and up, you're getting some resistance, and it's just gonna be a problem. All right, so we got some examples here, and we're gonna talk about the battery issues. So I'm just gonna grab this cheap Amazon meter here, and just to show you, so this one's got a low bat, but you can see there's nothing on the screen indicating that there's a battery issue. So some meters might not give you that. So to know if there is a battery issue, for one, the meter might turn on and off constantly, or you could kind of force it and know if there is a battery issue. So one of the things I would recommend doing is always check continuity. For one, you're going to get a tone that's going to use the speaker, and that could put extra load on the battery, and if there's a battery issue, it's pretty much going to go out. Another thing you can do is also just have the light on, and that would also kill the meter if there's a battery issue. So on this one, everything's still good. I have it on a continuity check, and let's check continuity. As you can see, it kind of just shut off and turned back on. If I go through the settings, it could also cause it to shut off and turn back on. Again, let's put it on continuity, so it's even kind of blinking a little bit, and checking continuity, and meter resets. So that's a good way to know, okay, my battery's the problem. And this is not going to be a meter you want to be using, because you might have some odd readings that are going to make you go down rabbit holes that are issues that are not true. So make sure that you are checking your meters and check your batteries. And that's it for today's video, and we hope you enjoyed and learned something new today here at Hero Appliance Academy. Don't forget to like and subscribe, and we'll see you on our next video. Till next time.